For doing simple bevel cuts and countersinks, Igems has an area that they used to call 2D-5X. Now it's found under the 3D-5X submenu. This define and cut, which are deprecated, meaning they're not going to be doing any more improvements to it, and it may disappear one day. But until then, it is sometimes a little bit easier way to add bevel cuts and such to simple parts versus using the 3D-5X, which is sometimes a little bit intimidating. So basic idea, you create a part like normal, but you don't add your toolpath. And then you can go into that sub-menu and first do define, click on the part, and it's going to open up this window here, a little 3D model of what you've got here. I usually like to kind of position my other part over here, and I can kind of resize this. You can hold down your right mouse button and spin this around, and hold down your middle scroll wheel to pan around and zoom in and out and such. And then you've got this little tool up here to also spin it around. So in this area here, we've got the listing of the different contours that are in the part. As you click on these, it'll highlight in red the one that you're working on, and you can also see over here in this little image in the background, it shows you what you're working on. And then you can also expand a contour. So if on this outside cut I just want to put a bevel on one edge, click on one of those edges. Again, it'll highlight it in the part, the edge that you're working on. And then over here you've got your different selections for the different types of bevel cuts. So if we want to do a top chamfer like that, specify your angle, how deep down into that cut you want it to go, into the material thickness, and then click on apply, and puts that on there. You can also see in this image over here, this solid line here represents basically where the tool path is going to go to put that bevel cut on there. Solid line indicates a top bevel. If we're a dashed line, that would indicate that it's a bottom bevel on the back side of the part. And if we wanted to also put that bevel, same bevel cut on this edge here, you can just click on that, apply. If you decide you don't want to do that, you've got the undo button. You can also, there's the choice of the eye, which is basically the same thing where it'll make the edge straight again. So we'll go ahead and put this back on there. And then if we want to put countersinks on the holes, we'll do the same thing as far as the angles and the depth. Click on the contour, click on apply. And then there's also, now this one's not particularly complex, but if you had a bunch of holes, you've also got the clone option here. So that you can take one that already exists and copy it around to other geometries. So I can click on clone, and down here at the bottom prompts me to select objects. So click on this one to indicate that that's the one that I want to clone, and then prompts to select objects. So then you click on the ones that you want to clone that to, and then you hit enter. So you can very quickly copy that around to the other holes there. So once you've got your model the way you like it, you can click on close. And by the way, if you ever come in here and your model's not showing up, there's this box here that you need to click to have it show. Sometimes that gets turned off or isn't on by default and can get confusing there. So once you've got things the way you like it, click on close. And now we can add tool paths to those cuts. So you can go into that sub-menu again, and now we use the cut command. Click on the part, and we've got this window here that comes up. So you've got your normal selections for type of lead-in that you want to use, whether you want to use tilted piercing, which if you're doing an Apex 60 head, generally want to do tilted piercing. If you want to use a different quality on the bevel cut, you can check that box and choose what quality you want to use on the bevel cut. Length of lead-in and length of lead-out, and then whether you want to use any sort of overcut, which we'll want to do on these holes here. Standoff, which if you get beyond a 60-degree angle and your nozzle might drag on the material, you can add standoff to pull the tooltip away from the part. And then how you want it to work through these different cuts. Normally you're going to set this to like bottom, middle, top. Then down here we have these two selections, speed by thickness and speed by edge length. What do those mean? I've got a little drawing down here trying to explain this. Basically, speed by thickness is going to look at the total length of material that the stream is passing through to calculate the feed rate. So on the vertical cut, it would look at this red line here, in this case 1/4 inch thick. It's basically telling it, you're basically telling it that you want to calculate the feed rate, assuming that all this material is here, which if you're cutting the vertical hole first, that would be the case. So you'd want to do speed by thickness on that. The other choice is speed by edge length on the countersink, where we've already cut away the center slug and that's no longer going to be there. If we do speed by edge length, then it's going to calculate the feed rate based on this red section here, because that represents the actual edge of material that the stream is going to be going through. If we chose speed by thickness in this case, it would calculate the feed rate based on this entire length here, about 0.354 thickness of material for it to go through. You can optimize your speeds a bit if you think a bit about as far as whether you want to use thickness or edge length, whether you're cutting material that is there or not. And all I'll do is I'll program a couple of these holes, a couple of the countersinks as speed by thickness and a couple of them as speed by edge length, so we can see the difference there. So now that we're ready to start adding some toolpaths, anything in yellow are contours that have not had any toolpath assigned to it yet. So we'll start with this hole down here. So I can click on the cut button and then put my cursor where I want to put the lead in. So we'll start at the 9 o'clock position. I want to go all the way around here, so I just hit enter and we'll go clockwise, and then the yellow line is my lead in. So the yellow length is the default length. If I want that, I can hit enter. If I want a different length, I can just move my mouse and left click, and then the lead in length will be adjusted to wherever my cursor was when I left clicked. And then for the lead out, same type thing, I can move it around, and when I've got it in a position that I want it in, I can just hit enter. So that was for the vertical cut. And now for the countersink, we see the yellow line here indicating that there's another edge here that needs toolpath added to it. So I can click on cut again, and we'll start at the same point, and I'll hit enter to go all the way around, and again we'll go clockwise. And then for my lead in, I'll just take when it locks in there, I'll take the default length, hit enter, and then same thing, lead out, when it locks in there, I'll hit enter. So we could do the same thing for the other 3 holes. There is also the clone tool here, so I can click on clone, and connects the little connector line here showing the cut that I can clone. Since there's only one, basically one contour here that has cuts that I can clone, that's the only one that this will connect to. So I left click to indicate that that's what I want to clone, and then I can click on the objects that I want to clone this to. So I just left click on each of these and then hit enter, and that gets copied around there. And we've got our cut sequence here. We've got our arrows we can use to move things up and down in the cut sequence if we get things out of order. If I do want to change settings on something, so on this first and second hole on the countersinks, I'll change those to be, change the engagement on these. So on the first one right now, we've got it set to speed by thickness. So we'll leave that one there. So that's going to be looking at that entire 0.354 length. And we'll do the same one we'll keep it the same on the second one, and then the third and fourth we'll change these ones to be speed by edge length. So change it, click on apply. There's other settings here you can adjust if you need to, length of lead in and such. And then can close it, and then can go to the other countersink, and we'll edit that one, and we'll also change that to be speed by edge length, and apply, and OK. Now we just need to add our cuts for the outside, so we'll do the bevel cut first, and then we'll do the outside cut. Right now, since I've got this set as bottom, mid, top, when I go to add the cut, it's going to assume that I want to do the vertical first. So I can either do that and reorder things, or I can change this to be top, mid, bottom, and that's going to start from the top of the part with the bevel cut and work its way down. And for the bevel cut, since we'll be cutting into material and it's all going to be there, I can do speed by thickness. If I did speed by edge length, it might cut too fast and cause a lot of spraying back. So we'll start here, end here, and we'll go this direction, and then we've got our lead in and our lead out there. And then for the outside cut, can do the cut command again. I'm going to start down here, and I'll hit enter to go all the way around. And I'm going to go this direction, and in that way, when we're traveling in the counterclockwise direction around here, the entire part is held into the material by these two edges over here, so I'll get better quality as I come along this the land here. If I go this direction clockwise, as I'm coming around here, cutting in this direction, when it gets towards the end here, there's going to be less and less material holding it in place, and the part will start to move a bit, so you get a little bit better quality if we go counterclockwise around this part. So I'm going to left click to go this way, and then we've got our lead in and our lead out. So we'll go ahead and close that, and then we do our order button like normal, and we'll go ahead and process this and take a look at the preview. Here on the vertical cuts, we're going 29.97, and then on this countersink we're doing 21.21, and on the next countersink it'll be 21.21 because we did those ones by thickness. And then on the next two, on those countersinks, we're going 47.79 because it's looking at that edge length and cutting those faster. So that's how these buttons here work. If you have any questions on that, let me know. Thanks.